Hello everyone, and welcome to our third video lecture. This is Dr. Mo. I'm going to be talking to you today about your week 3 assignment. So this week we're going to perform some ANOVA testing and also chi-square test. So for the first problem, they're asking you to determine if there's a significantly different mean for salaries between pay grades. I mean, any good pay program should have different average salaries per grade. I mean, if people in all grades are not paid significantly different, then what's the point of the pay grade? So we want to conduct an ANOVA test to see whether or not all salary means are equal, so that's going to be our null hypothesis, versus the alternative, which is at least one salary mean is different from the rest. So the first step is to complete this table here, where we're going to find the salaries in each grade level. So if we go back to our data, select the salary column, it here, and now I need to select the grade column. Let's put that here. Now I'm gonna sort this data by grade, just to see how many or what are the salaries in each grade level. So we're going to sort it by grade. And now I'm going to copy the information into my table. So first grade A. Now this is grade A, so I'm going to put it under A. And then grade B. Put that under B. Then grade C, grade D, grade E, and finally grade F salaries. Right here. So you can see that grade A has the lowest salaries, and then grade F has the highest salaries. But again, this is just a sample. We need to figure out if this is statistically significant. So we're going to conduct an ANOVA test. So our significance level, we're going to again pick alpha. We're going to be running an ANOVA test because we're comparing multiple means, right? Multiple groups. They're not just two groups like last week, where we used the t-test for mean difference. Here we're comparing multiple means, so we're going to use an ANOVA test. And our decision rule once again is going to be if p is less than alpha, right? Which is 0.05. So if p is less than 0.05, we're going to reject the null. Okay, make sure you fill in all of this, all the questions you have to fill in. Some of you jump questions like why is this test, things like that, a null alternative. You have to fill in all of this. I'm not going to do the entire assignment, obviously. I mean, you have to do your part. So I'm going to conduct the test now. So we're going to go to data analysis. We're going to do ANOVA single factor, and we're going to be selecting our table here with the salary range. You can also say that there are labels in the first row, as you can see here, and press OK. So here is the result of the test. So let's copy that to our assignment sheet. They're saying put it on K08. So right here, put everything. Okay, so quickly by looking at the p-value, you see that it's a very small value, almost 0. So looks like we have enough evidence to reject the null hypothesis and conclude that there is at least one mean salary that's significantly different from the other. Okay, so and you can see here the sample averages, but based on this p-value we can make this determination. Okay, next we're asked, okay, since we were able to reject the null hypothesis, they want us to find which pairs of means are actually different. Is it group A and B are different? Is it A and E are different? A and F, and so on. So we need to find which pairs are different. So this is a bigger table that we have to construct here. So I'm just gonna do the first one for you. So first I'm comparing group A to group B. So in order to compare group A to group B, the first column says the mean difference. So I have to find the absolute of the difference between A and B. Okay. Actually, let me redo this because I don't see the group names here. So let me just delete this. Let's delete this. Let's rerun the ANOVA. And let's just highlight the labels. This way we get the labels in the results. Oh, here we go. So now we have the labels. And go back and paste it. K8. Okay, so now I have the groups, have their averages, everything is good. Okay, so first I need to find the mean difference. So for that I need to find the absolute of the difference in their means. So that's gonna be equal to absolute of this minus that. Okay. Now the t-value, since we're trying to determine if the difference between these two groups is significant, so we're going to use the same alpha we used, which is 0.05, and if you look at the t distribution for 0.05, you will find that this value will be 2.015. So throughout this table you're going to always use t equal 2.015. Okay, now we have to find the term we're going to add and subtract from the mean difference to find the range. So that plus minus term, there's a formula for it. So it's equal to the t value times square root of the ms. There is ms. So we're going to be using this sorry. One second. Okay, so as I said, it's equal to the t value times square root of mean squared error times 1 over the sample size for A, which is this guy, plus 1 over the sample size for B, because I'm comparing A and B, which is this guy. And I close the parentheses one more time and I'm done. 2.87. Okay, so the low value now is going to be the mean, minus this guy, and the high value is going to be the mean plus this guy. So the low value equals mean minus this, and the high value is equal to the mean plus this. Now, is the difference significantly different from 0? Yes. How did I know? Because this interval does not include the 0. So I can reject the null hypothesis that there is no difference between the two groups. So your answer here is going to say interval does not contain 0. So because the interval does not contain 0, then we conclude that the difference is significant. And you're going to repeat that for all the pairs of groups until you find which ones are significantly different and which ones are not significantly different. Okay, once you're done with that, now we want to compare gender. We want to study gender and grade level to see if male and female are distributed the same way across different grades. Because it is possible that if you have, for example, females mostly in grade A and males mostly in higher grades, then maybe that explains the difference in salary. So we want to know if the distribution across grades between males and females is similar or not. So to do that, we will conduct a chi-square test, and our null hypothesis will be that males and females are distributed evenly across the grades, and the alternative, of course, if we reject the null, is that male and females are not distributed evenly across the grades, which means that there is a significantly different distribution between male and females across grades, and this could be the reason why their salaries are significantly different. So again, we're going to pick our alpha to be 0.05, but we have to do some work first to find the actual distribution and the expected distribution so we can run our chi-square test. So let's copy the data regarding gender and grade. So that's what we need. Let's put this data here. Yeah, let me put it here. Okay, and let's sort it by grade. Now I need to sort it by gender after grade, so let me sort it again. Need to sort it by both factors to make our life easier, so custom sort by grade, and then add another level sorted by gender after that. Okay, so now I know, for example, that I have 12 females grade A. I'm gonna go here under females grade A, I'll put 12, and then if you go back, you will find that you only have 3 males grade A, so you're gonna go here and put 3, and so on until you fill up this table. So I filled it already, so let me just copy and paste it here. Special values. There we go. Now I'm gonna need the totals across columns and across rows. So let's find all of this. This is the sum vertical. To copy that here. Then I need the horizontal sum. here, and I'm gonna need the total, which is, you can add either this or that. So 25 plus 25 is 50. But let's just do it. Remember, you have to provide me with formulas for everything in your worksheet, so I know where the numbers are coming from. Okay, so this is the actual distribution of employees from male and female across grades. Now we need to find the expected distribution. So for each one of those, for example, I want to fill the first box here, which is A and male. So I'm going to take 15 multiplied by the 25, because I'm doing column 1 and row 1. So 15 times 25, and divide that by 50. So equal this times that divided by this. So I get 7.5. Now for this one, I'm doing also column 1 but row 2. So I'm going to say equal column 1 times row 2 divided by the total, get 7.5, and so on for the rest of it. So I'm going to do one more. So equal column 2 times row 1 divided by total, and so on until you're done with the whole thing. Once you're done with the entire table, so I'll give you the numbers, but again you have to do the analysis. I have to see columns and formulas in your work to give you credit for it. I'm just going to put the values here so I can perform the test for you. So that's the expected distribution you should get if you keep on doing what I was just doing. Okay, so now they're telling me to go to cell K54 here and perform the chi-square test. So we're going to equal chi-square dot test, left parentheses, and then just press on this button. Okay, so they're telling me, okay, where is the actual distribution? Or here is my actual distribution. And then here I need to enter the expected distribution. This is the expected distribution. Okay, and press OK, and you get the p-value. So this is the p-value. So as you can see, the p-value is less than 0.05, which is our alpha. So we conclude that we can reject the null hypothesis and confirm that the males and females are not distributed evenly across the grades. Okay, so this could be the reason why their salaries are significantly different. So we'll have to look into that, if actually this is the truth or not, and we'll do that next week. Okay, and as usual, at the end you have to comment on the results and what you learned from this exercise. Hope this helps, and if you have any questions, send me an email.